Hello, my name is Aidan Arabzadeh, and this is the capacitor visualizer. This circuit provides a good introduction to the behavior of an electrolytic capacitor in a DC circuit. On my breadboarded prototype, I used a 9-volt power source, a power diode, 3 470 ohm quarter watt fixed resistors, 2 12mm momentary single pole double throw PBNOs, one 1000 microfarad electrolytic capacitor, one 5mm bicolor, and one 5mm yellow LED, and a few jumper wires. Now let's dive into how this thing actually works. At rest, the circuit has no current or voltage, since the input S1 is not activated. When I push the PBNO, the circuit becomes active, and at the junction before R1, the current divides down the two branches because they're in parallel. When the circuit is through R1, the capacitor is being charged. Positive charges are building up on the lead plate, which are repelling positive charges on the other side, making the other lead negative. There's now potential energy. As this is happening, the bicolor LED is becoming dimmer and dimmer. When the capacitor is basically full, after 5 tau, it provides infinite resistance on the positive lead, so the current through is blocked. The bicolor LED now turns off to signify that the capacitor is fully charged. Tau is the capacitor voltage growth over time, calculated with the formula R, resistance, times C, capacitance. Specifically, 1 tau is the time the capacitor takes to reach 63.2% of the difference between its current voltage and its total capacitance. The circuit is now stable, with only the yellow LED on. After I release S1, the capacitor stands in as a temporary replacement for the 9-volt source. Now all the positive charges flow clockwise out R1 into R2 through L3 and then through L2 until the capacitor is drained of all of its energy. To discharge the capacitor while it has energy, I can press the secondary input, S2. Now the current takes the path of least resistance, and the capacitor gets rid of all the charges it had by discharging into itself. This is my prototype of the capacitor visualizer. Thank you for listening, and I hope you learned something.